Thank you for such a great introduction. Yes, so as you mentioned, this is a collaboration with Mykola Mahortych, Victoria Zatisheva from Bern and Ani Bakumyan from Bern University. So some of members of our group, Marta Stolze, and University of Zurich, Alexandra Urman. So it's indeed a very sort of it's still ongoing study. We published a preprint, but we already got some good reviews from the ICA, International Communications Association, conference where it got accepted. And we just wanted to really, because we all know that this is a very salient topic, generative AI, and we wanted to see how can we sort of use it in a very well, because there is a lot of discussion going on about generative AI in general, and we wanted to see what is the potential for misinformation detection. Oh, sorry. Okay, now. There have been some concerns around generally AI-driven systems in societies. Oh, I'm sorry. Okay. About, for example, concerning content distribution. So we know that there are information curation algorithms, a process of selecting and presenting content from pool of data. And this has been recognized as one of the crucial factors shaping political environments worldwide and affecting information flows. And of course, there are some ethical concerns with that, such as exposure to propaganda, algorithmic bias, and political micro-targeting. Can I just ask one question, like, what is the group right now here? Do we have communication scientists, economists, or also some computer scientists? Volker, maybe you know, just so that I understand a bit to whom I'm addressing all these questions and to whom I'm presenting. So it's very, very diverse and interdisciplinary, which is great. Because this is also a study that covers various dimensions, so it's not a strictly computational study. Yeah, so we have these ethical concerns about exposure to propaganda, algorithmic biases, and political micro-targeting. All these questions have been discussed when it comes to algorithms on social media, platforms in general, search engines, etc. And of course, with the with the boom of large language models, and particularly the chatbots connected, powered by these systems, there were other concerns coming on top of that, but also new possibilities for content analysis, because we all know that these systems are powerful, that they allow new ways of analyzing text, and of course, we all know how much information is out there in the online environments and how problematic and difficult it is to deal with this abundance of information. So it is kind of a very promising technology for anybody who is working with text. And of course, we were wondering if this is something that could also be used for us, for the society. And so far, we have had different ideas on how to tackle online misinformation. So one such idea was to counter it. It's quite a popular proposal and has been implemented in many instances when you just counter misinformation and debunk misinformation, which we all know by now. There are fact checkers, news organizations use this, and it shows promise. Then another idea is to educate, which sounds simple, but is quite difficult to implement for various groups in the society, in particular for underprivileged groups. But of course, still a very important way of dealing with misinformation. And the third way is using some form of automated tools to prevent the spread of disinformation, or automatically identifying them and removing such false claims. But these types of automations have been connected to a bunch of concerns. They are problematic due to the limitations of automated content analysis, in particular when it comes to dealing with emotional statements or statements containing semantic complexity. So because LLMs are so promising for text analysis, there have been already a few papers on this topic. And all of them are actually quite promising. So for example, the first very small study shows that there's like 100% accuracy with identifying false claims. Follow-up studies, more comparative ones, also show some promise. But what is still missing, and what we wanted to really tackle, is the focus on different languages, because so far it's mainly in English, as well, pretty much all research is very English focused. Differentiation of statements, so in different languages, but also partially true, conspiratorial content, and so on. This is the gap that we sort of tried to address. Yeah, and this is what the questions were for us. Yeah, what are the differences? You see my screen again. Sorry, it's just a little confusing here because it's jumping from one slide to another. What are the differences in chatbots' abilities to distinguish between true, false, and borderline statements? What are the differences in chatbots' performance in different languages? And how does source attribution of statements influence their labeling by the chatbots? And the idea was, of course, to compare two chatbots, not LLMs, which I know I received this question quite a bit by now. We are not comparing LLMs per se, so large language models, but we are comparing chatbots, so which have different settings, which have different guardrails, and we really wanted to compare how different chatbots will work with such statements. So what did we do? We used 25 statements, so examples with 25 statements, some of which were false, some of which were true, some of which were conspiratorial or so-called borderline, so partly containing true information, but nevertheless misleading. And we focused on different topics, quite popular, famous topics that are often targeted by misinformation claims by different political actors, such as COVID, Ukraine, climate change, LGBTQ plus debates, and Holocaust denial. So these were our topics, and we had true, false, conspiratorial, borderline statements for each of these topics. We designed them ourselves, but they were based on existing claims from fact checkers. So we did not sort of, well, it's hard to say, we did not make up false statements, I like to say, but obviously we made sure that they sound clear and are possible to sort of understand, something that people could potentially input into those chatbots. But this is a unique data set, so they do not exist in this specific formulation. They are unlikely to be found in the training data for ChatGPT or Bing Chat or Microsoft Copilot, as it is called now. Then we wanted to see how chatbots will deal with different sources, so whether or not there will be any bias against specific sources, such as Russian sources or US officials or US social media users, and we assigned them to these 4 options. Russian social media users, US social media users, Russian officials, US officials, and none, so no source given. So, and then we wanted to test whether or not they will be able to deal with complex theoretical concepts like disinformation, misinformation, and conspiracy theory. So our prompts contained this kind of task. We constructed a task in which we firstly we provide definitions of our theoretical concepts. So we define disinformation as false or misleading information deliberately created and or spread to deceive people, misinformation as false or misleading information created or spread unintentionally, and conspiracy theory is a belief that a political or social event is the result of a secret plan made by powerful people. So, of course, we received this question already. The intent of the source is very difficult to know in general. And of course, how would a machine know it? We did it deliberately so that we can see whether or not, firstly, it will identify this task as something that they are not able to deal with, because they should be, like, whether those chatbots are smart enough to identify that this is that they will have no means of identifying intention. And secondly, we wanted to see if there will be any bias against the sources that we provided, which was probably our primary concern, as we do know that algorithms generally are prone to bias, and especially if we're talking about such systems that are trained on a lot of data existing out there, it was important for us to test. Then we asked so we gave two tasks. First, to identify whether this is true, false, or partially containing true information statement. Secondly, whether it can be described as dis or misinformation, and if it can be treated as conspiracy theory. One example here is approved COVID-19 vaccines provide strong protection against severe disease, hospitalization, and death. And here, at the end of the prompt, we would always include a source. So in this case, Russian social media users. Then we had a code book, which consisted of various, some of them rather simple variables, others were a bit more complex, but the idea was here to first see whether or not. So we had some baselines for those statements, like whether or not it's true, false, or conspiratorial content. But for other variables, we didn't have a baseline, for example, for misinformation and disinformation, because there is no true or wrong answer. We wanted to know, it was more explorative, this analysis, and we just wanted to know how they will identify this based on the source, whether they will identify it at all. So here we have, gave an answer to the question, because sometimes they would refuse to provide an answer. So the first variable was about whether or not they actually dealt with this task that we gave them. Then whether or not they identified false, true, borderline correctly, conspiratorial correctly, and then we looked at whether or not they identified misinformation or disinformation, or sometimes both, or didn't give an answer, and what was the assessment of the source. So sometimes there was a positive assessment of the source, sometimes they would like call out Russian sources and say, be careful, Russian sources provide disinformation. So then we collected all of this data, and the first analysis was just some descriptives. So first of all, we have some promising results on the identification of veracity of information. 72% of prompts were identified correctly. ChatGPT performed better in all languages with an accuracy of 79% compared to 66%, but in English. we see that in Russian language, ChatGPT performed much worse with only 70% accuracy. Bing Chat also responded accurately in 70% of instances, but Ukrainian was really much worse. So 68 and 66% respectively. And we also see that sometimes there were completely like nonsensical answers, in particular in Ukrainian, when they wouldn't understand the question, they would not perform on the task at all, and give nonsense or answer to different questions. So there were a lot of those as well. The next one was about identifying conspiracy theories. And here we were quite surprised because it was actually both chats were, well, ChatGPT in particular was performing really well in most languages. But the non-response, so for Bing, the non-response rate was much higher in Russian and Ukrainian, because I guess it was a more complicated task for Bing. But we found these results rather promising. Well, the ChatGPT results promising because we thought that it sort of allowed identifying hidden meanings in text based on our definition. And we found promising, even though, of course, I have to make a disclaimer that it's not, we do not know to what extent, because these statements are known and unknown conspiracy statements, we do not know what actually, what is in the data set that these LLMs were trained on, and whether or not they're just picking it from the training data and not actually analyzing them based on our task. And then we looked at distribution of misinformation and disinformation labels. Overall, disinformation is used much more by all chatbots in most languages, but particularly high for ChatGPT responding in Russian. So one of the possible explanations is that in Russian language, misinformation is not actually used it's like a neologism. So it's not, mainly disinformation is used in Russian. So it's possible that just due to these linguistic factors, disinformation is so much more commonly used in Russian. And then the most common response for ChatGPT in English is that the statement can be both dis and misinformation, which on the one hand sort of goes against our task because we clearly ask to identify it, but on the other hand, it is a much better response because this is what we hoped would be, because chatbots cannot actually identify the intent behind spreading this or that claim. So therefore, we actually found this the most preferable result, and we were sort of pleased with the performance of ChatGPT in this case. Bing Chat was mainly was not doing that well with this task because often it didn't even understand the question, or even would just randomly use this or that statement without actually going into detail, because ChatGPT would always provide some kind of justification for this or that choice, and Bing Chat would just randomly spit something out. Yeah, and so then we wanted to see the source bias, if there is any. So overall, we see that there is, based on this descriptive analysis, and I will, in a minute, I will go to regressions, but here, our very first analysis showed that there is some kind of anti-official bias of ChatGPT, because mostly the statements with official Russian officials or US officials were labeled incorrectly. But we also saw some results pointing at Russian sources being more connected to incorrect identification. But the thing is that when we did regression analysis, and I'm sorry for this visualization, it's not perfect, but I didn't know how else to show it. We did not find actually any significant effect of actors, so of sources of information on the outputs. So we cannot actually say that there is any source bias, at least not with our study, not with our data set. In general, we don't find any statistically significant factors influencing the incorrect assessment of whether the statement is true, false, or partially true. We don't find significant source bias. But what we do find is that ChatGPT is more likely to give a clear answer compared to Bing Chat. Both chatbots were less likely to provide answers about sensitive topics like Holocaust and Russian aggression against Ukraine, which points at perhaps some guardrails in place with regard to sensitive political topics. And then we, of course, find significant differences by language. So both chatbots are less likely to provide clear answers in Ukrainian and in Russian, which, of course, these are lower resource languages. So we already know limitations of LLMs in low resource languages. And therefore, we see this difference quite stark in the study. And we also find that the effect of prompt topic was significant for identifying misinformation and disinformation labels. In the case of the Russian aggression against Ukraine topic, both chatbots were more likely to treat claims as intentionally false, which is also, I find, interesting because it points at rather, so compared to other studies on algorithms, where we see much more source bias, here we see this topic bias, which is interesting. We can discuss what it means later. So what are the conclusions? So overall, the accuracy of label assigning is really quite good, sometimes above 80%, especially for ChatGPT. So ChatGPT is performing better. And of course, we only looked at ChatGPT 3.5. But a disclaimer, our results are based on one prompt without pre-training, any fine-tuning. And of course, we see the rather classic bias concerning low resource languages like Ukrainian, performance drops, lack of answers, or nonsensical answers, and so on. And then we, of course, see more errors with Bing Chat, but no statistically significant bias against sources. So overall, if I can say, I do think we can see some potential for content labeling using chatbots, including some highly challenging tasks, even though it's not yet fully possible to say how well they work on a large scale, and we need to do more studies on that, and our group plans to do more studies on that. And I think that we should continue exploring this topic in the future. Well, that's all from me, and I'm looking forward to your questions.